Hi, my name is Jonathan Villanueva, and today I'm going to be presenting Python SAT, which is my final project for Component 70. It has been in development for about a month and a half now, and I'm really excited to showcase this project. I've worked very hard on it, so without further ado, let's get right into it. So what is Python SAT? Python SAT is actually shorthand for Server Administration Tool. It's a automated TCP ICMP port scanner, which is designed for system administrators to check the responses of servers and system services. And it currently supports installation and use on both Linux and Mac OS. It was built entirely by me. Who is this built for? It was built for server admins or hobbyists who need to check the statuses of their servers in bulk. In respect to that, it focuses a lot of its features on that specific user base. It's supposed to be ease of use for these server admins to check servers in bulk. Python SAT is still receiving features and updates as of today, and ignore the slide, it's actually on version 2.0, not 1.2. Here are some of the features and overview of the project, some of which we're going to cover later in this presentation. However, the main ones that we really are going to focus on are the concurrency and process threading for optimal performance, and TOML for user configuration. With that said, we can now move on to looking at how Python SAT works. Python SAT uses a concurrency model to asynchronously connect to servers defined by a user configuration file written in TOML. A user can create or define their own TOML files using an argument parser, and it also has two dependencies: ICMPlib and requests. The rest of the project is built in. All the dependencies and libraries I built myself. So what is a TOML file? A TOML file is a configuration file that uses key value pairs that can be mapped to a hash table, which is equivalent to a dictionary in Python. I chose TOML for this project specifically because it was super easy to read and modify. It's cross-compatible into other languages, and it has built-in support within Python versions past 3.11. Now that we have TOML files covered, we can take a look at how networking works inside of Python SAT. Now, we don't need to understand everything about networking to understand how Python SAT works, but we do need to know how computers communicate fundamentally with one another. So computers communicate through these things called sockets, and they communicate amongst each other with these things called packets. Python SAT works by using both ICMP and TCP packets. It uses ICMP packets to make sure that a server is up, and it uses TCP packets to check if the service is up on the server. We don't really have to dive too deep into how these really work right now, but just know that there is a special kind of TCP packet that's sent, which is a HTTP GET request, which checks if a web server is running on the server, which is important to know if, if you're hosting a web server, you want to know that it's up. And a regular TCP packet won't capture that information, but a HTTP GET request will. All right, so the last thing that we have to take a look at is concurrency in Python. We're going to try to explain how this works inside of Python SAT specifically, but essentially, we want to use concurrency inside of this program because when it comes to working with network devices, not all devices will respond. So if we did this through like a traditional, for loop, it's going to, have to wait until each device responds individually, which is very inefficient at a large scale. So if I have, 5 servers I have to check, I have to wait for each individual server to check the connectivity. Whereas if I use something like a threading module, I can check each server simultaneously and have an extremely fast output. So now that we understand how Python SAT works under the hood, we could now take a look at a live demonstration of the usage of Python SAT. I have a terminal set up here. If I run sat-h, I can see all the options that I have. Let's say I want to, see the verbose logging of my project. So we run sat-v, and we see the nice little log messages that pop up on our screen. After which we will get a little box of errors, and then we'll get our connection table here. If I wanted to, see just this connection table here, all I have to do is run sat, and like that, it's going to timeout 8.8. Let's try again. All right, perfect. There we go. But that's a nice little segue into seeing how, if not all connections are made, then it will still continue to run without any hiccups. Ignore the fact that Google's DNS cut out for me for a moment. It's fine.